To warm up for 6.1, we are going to factor these expressions. The first one, how can we factor it? It is not factored yet. It doesn't really have to do with the y. What's the first thing we're supposed to check for when we factor? What is it? A GCF. What's our GCF? 2. Those can both be divided by a 2. Where else do I write a GCF when I factor it? Outside some parentheses. And what's left over? 1 minus y. That's it. That's all we got to do. Factor out a GCF. Next one. What can I factor? A 3. So again, when we factor out a GCF, it also gets written where? On outside of parentheses. What's left over this time? 1a plus 2b. Good. Nothing else we can factor, so we leave it there. The next problem is one that we probably did not review very much the last couple days. Jamal? Yes, on this one we got to use our square roots. These are perfect squares. So we've got the difference of perfect squares. It will factor into 2 binomials. What will go in those parentheses? Kian? Y minus 4, and what about the other one? Y plus 4, good. We square root both the front and the back. And we put those in the fronts and backs of our binomials. One of them is subtraction, one of them is addition. All right, number 4. How are we going to be able to factor this? Can we use the X method here? No, we've got to use bubbles. First, what should we check for before we decide that? A GCF, is there one? No. It's got 3 terms, and the leading coefficient is not equal to 1. So that's why we've got to use bubbles. So I'm going to make a little space up at the top. Hopefully we already wrote down our objective so that I can show my work for number 4. First, it's important to know what our signs are going to be. What do we think? Positive and negative. Good. If we have a negative constant, we need one of each. What are we looking for? Good. We're looking for a positive 7. What are my only options for my first bubble? 1 and 3. For my second bubble, I've got a couple options. Deja? Negative 2 on top. Okay. So notice that Deja made one of her numbers positive, one of them negative. Negative, positive, that's what our signs had to be. And if we multiply 2 and 3, we get a 6. So that's why it's a valid option for us. When we connect our bubbles, what operation are we doing here? Multiplying. 1 times negative 2 is negative 2. 3 times 3, 9. When we combine them, what do we get? 7. So we know that these are the correct bubbles, and we can use them to write our answer. Who can help me fill in my answer? Sure. X. Plus 3. Good. And my other parentheses? Natalie? 3x minus 2. Remember, you can always double check yourself by making the little smiley face, seeing if the right things are lined up, which they are, so that is our answer. All right, we've got a couple notes today. The first one, to simplify a fraction, simplify the numerators and denominators, then look for common factors. Sometimes when we simplify the numerators and denominators, we will actually have to factor them. So if you want to put a little note by simplify, that sometimes that means we are going to factor, you could do that. This is also why I gave you one worksheet where you were supposed to simplify fractions, because that's what we're doing today. It's just going to be a little more complicated than when you were simplifying fractions that only had numbers. Our other note for today is that the denominator can never equal 0. That's a rule you should already know, but it's important to be reminded of when we start working with fractions. On our first example, we need to simplify the numerator and denominator separately and then see if there are any common factors that we can cancel out. So if I am trying to factor my numerator, what could I factor out? A 3. Both the 3a and the 6 could get divided by a 3. When we factor out a GCF, it goes out in front of parentheses. What's left to go inside the parentheses? A plus 2. In my denominator, do I have any common factors? No. Is there any way I could factor this denominator? No. So it's going to stay the same. So, yours is different on your paper. Let's make it the same as yours. That'll make it more interesting. So let's change this to a 3b like is on your paper. Now, do we have any common factors? Yes. What is it? A 3. Okay. That'll make this more interesting. Otherwise, there would be nothing for us to simplify later. And when I take out a 3 from the denominator, what do I have left? A plus b. Now, what's a common factor from both my numerator and my denominator?
3.
The 3. Now, the parentheses binomials are stuck together. So we cannot cancel out those a's because they are attached to different things. This one's got a plus 2, this one's got a plus b. So the a's cannot cancel out. The 3's can because they are out in front of parentheses. They're on their own. If you wanted to, you could have rewritten this with a dot before your parentheses to show the separation. You do not have to do this, but this shows that those 3's are definitely out on their own and they can cancel out. So what would be left? A plus 2 over a plus b. If you want to leave them in their parentheses, you can. You don't really have to because there's nothing else around them. But it might be a good practice just to always put binomials in parentheses. I want to emphasize that you cannot cross off those a's. If it's got a plus or minus sign right behind it, you can't just cross them off. Even though I say that, and I'm going to say it a lot of times, I will still have people on quizzes and tests tell me the answer to this is 2 over b and get it wrong. If you're going to cross out something that's in parentheses, you have to be able to cross out the whole set of parentheses. We have questions about that? Okay, let's try another one. How can we factor our numerator? Jamal? We use square roots. So this can factor into two binomials. What are they? X minus 3 and x plus 3. Now looking at my denominator, I'm going to go ahead and leave that first set of parentheses alone. But I'm going to rewrite that second set of parentheses in my denominator. How do you think I want to rewrite this second set of parentheses? X plus 3. They're both positive. So all I'm doing is rearranging the x plus 3. I really didn't change it. I just rearranged it. And now what do we notice? What's a common factor?
X plus 3.
X plus 3. The whole set of parentheses matches top and bottom, so it can cancel out. So what are we left with? X minus 3 over 2x plus 1. Again, if you want to leave them in their parentheses to know that they're stuck together, you can do that. Questions about 2? All right, on 3. Can I factor my numerator? No, we can't. It's a monomial. Monomials cannot really be factored, so I'm just going to leave it as a squared. I'm going to put a dot in there times b squared so that I remember those are two separate factors. They're just getting multiplied together. If you don't put the dot, that's fine. You don't really have to. I'm just doing it for emphasis. In my denominator, what is my GCF that I could factor out? What do those terms have in common? So we're looking just at the denominator. So I'm looking just at a squared b minus b squared a. So these are my two terms. What do they have in common?
The square.
Not the square. They both have something that is squared, but that doesn't mean I can factor that out. They each have a b and they each have an a. So I could factor out a b from both of these. Remember doing these? We did them chapters ago. If I'm factoring out an AB, why can I not factor out a B squared? Which one does not allow me to take out a B squared? That first term that has just a B. If this one doesn't have a squared, I can't take out a squared. I can only take out a single B. Why can't I take out an A squared? Because in the back, we just have an A, not an A squared. So that limits us. Now, if you need to rewrite this second term as AB squared, you can. That doesn't change anything. If you need it to be in the same order, that's fine. Doesn't really matter to me. It doesn't change our answer. Now, when I go to fill in my denominator now, where else do I write my GCF? Outside of some parentheses. So we have an AB outside parentheses. What's going in those parentheses? A minus B. Good. That's what's left over when I divide down here. In the first term, the b's cancel out completely. Squared minus 1. 2 minus 1 leaves me with a 1. So just a plain A to the first. In the back term, the a's cancel out completely. B squared divided by B is just B. Now, I might recommend for this first part of it, just to visualize it, rewriting your denominator with multiplication dots also. Because we can simplify top and bottom now. What's going to simplify on this next part? We can simplify the a squared over a and the b squared over b that are outside of parentheses. So I don't know if you want to put a little circle around those to show that's what we're simplifying next. What are we going to be left with in the numerator? A times b. If you want to put the dot in there still, you can. You don't really have to anymore. And what are we left with in our denominator? A minus b. Can I cancel out these a's and b's now? No. The ones in the denominator are stuck together in parentheses. So they could only be canceled out by another a minus b stuck together in parentheses. So that would be our final answer. Will my numerator factor on number 4? No, it will not. If you want, though, since it's a binomial, you could write it in parentheses to remind yourself that it is stuck together, n minus 3. In my denominator, what can I factor? 4. A 4. What's left over? N minus 3. So what can cancel out? N minus 3's. If parentheses match perfectly, they can cancel each other out. Now, I want you to be careful. What's left in your numerator?
4.
A 1. Good. And in my denominator? 4. A 4. You have to have it as 1 over 4. If you were to change this to just being 4, you would be incorrect. 1/4 and 4 are not the same number. Questions about how that works? Okay. Continuing on to the back. Let's do a couple more together, and then I'll give you some time to try some on your own. Will my numerator factor on number 5? My numerator? The top? So we could write 32 as being prime factors, but that expression itself does not really factor out. It's a monomial. So if you wanted to write this as like 2 times 16n, you can. It's not wrong, but it's also not very useful. So if it's a monomial, I would leave it alone to begin with. Just leave it as 32n. Now in my denominator, what could I factor out? I think bigger than a 2.
4.
A 4. What else? 4n. Good. So we could divide both of these terms by a 4n. That gets written outside some parentheses. What's going in those parentheses? 7n plus 4. Now what's going to cancel out or reduce? think Danielle said it. The 32n and the 4n can cancel or reduce with each other because they're not inside parentheses. They're not attached to anything else. The n's cancel each other out completely because they match top and bottom. If we were to simplify 32 over 4 as a fraction, what would the 32 turn into? An 8. So we have an 8 left in the numerator. What about the 4? What would it turn into? A 1. So we don't really have to write it because 1 times, what else is left down there? 7n plus 4. That's the same as it just being 8 over 7n plus 4. With or without the parentheses in the bottom. I like to leave them on, but you don't have to have them in the very end. Number 6, what can I factor out in my numerator? A what? Just a 9, right? That's what I'm factoring out. What's left over when I factor a 9? P minus 9. Will my denominator factor? No, it's a binomial though, so I could write it in parentheses. What's going to cancel out? The P minus 9s. What am I left with in my denominator? A 1. Do I have to write it as 9 over 1? No, that's the same as it just being 9. If you write it as 9 over 1, that's fine. It's the same thing. But if you just put 9, it's also all right. So from the very beginning of this problem, if we see two terms added or subtracted together, it might be a good idea just to put parentheses around it from the very beginning. Anytime you see two terms either added or subtracted together, it's a binomial. We could go ahead and put parentheses around it just to remind ourselves of that. If there were not any symbols in between them, like it was just P9, that means they're being multiplied. But if they put a symbol in between it, they're stuck together as a binomial. Or if there are three terms, like we'll see on the next problem, then it's a trinomial, again, stuck together. On number 7, we are going to see a new way of factoring that we have not had to deal with yet. How are we going to be able to factor the top? The X method. Oop, too far. We have to factor our numerator with the X method. Again, if you want, you could put parentheses around your trinomial. You don't really have to because we know we're going to factor it with our X anyway. But you could also put parentheses around the binomial in the denominator. Now when we factor our numerator with the X method, what's going in the top of my X? 12 in the bottom. What numbers do we need to fill it in?
4 and 3.
A 4 and a 3, good. So my numerator factors to be what?
X plus 4, X plus 3, plus B.
Good. Yes, we'll use a b because that's our variable, but you are correct. B plus 4, b plus 3, and my denominator is still b plus 3. There was nothing to factor there. So what happens? The b plus 3's cancel out. Those parentheses match perfectly top and bottom. So what are we left with? b plus 4 over 1, which over 1 you don't really have to write. You could just put b plus 4. If you have your parentheses around it still, that's fine. You don't have to have them. All right, let's work on number 8 together. Now again, from the very beginning, if you want to put parentheses around your binomials and trinomials, you can. Will my numerator factor? No, it will not. It stays a minus 2. What method will I use to factor my denominator? The x method. What number am I putting on top? On bottom? What two numbers are going to work out for me? Negative what? Negative what? You're right, they will both be negative. Negative 10 and negative 2. Yes, they multiply to a positive 20, add up to a negative 12. So how do I use that to write my factored form? A minus 10, A minus 2. What cancels out? The A minus 2's can cancel out. So what's my answer? I agree I will need an A minus 10 somewhere. May? Good. 1 over A minus 10. Remember, if there's a 1 in the denominator, we don't really need to have it. But if there's a 1 in the numerator, you have to put it there. The same reason why on that one that equaled 1 over 4, we didn't just write a 4. If there's a 1 left over in the numerator, we have to put it there. Questions on number 8. All right. What's different about number 9 from the ones that we've done so far? We got to do the x method on both of them. X factoring on both, top and the bottom. So let's start with our numerator. What's going in the top of my x? And on the bottom, what numbers are going to fill in my sides there? A negative 4 and a positive 1. So when I go to write my parentheses, what goes in them? Good. Then we go down to our denominator. We do our x method again. What goes in the top of my x? The bottom. What fills in my sides? Negative 8 and 1. So when I go to fill in my factored parentheses, what do I have? Good. Now I'm going to write mine a little bit different just to show you that it doesn't really matter. I'm going to put x plus 1, x minus 8. What can I still cancel out even if I wrote it this way? The x plus 1's can still cancel out. Even though they're not right on top of each other, we have the same set of parentheses top and bottom, so we can still cancel them out. So what are we left with? Now, unfortunately, I'll have some people on the test, final, quiz, whatever assessment we're taking tell me that the answer to this is 1/2.
You gotta do that?
No, you shouldn't do that. Why is that wrong?
Put the X's.
Okay, we need to keep the x's. Can we simplify the 4 and the 8?
No.
No. If you need to keep the parentheses around this to remind yourself that those are stuck together, you cannot do anything to simplify them unless there's more factoring to do. Keep your parentheses there. There's nothing else here that's going to factor or simplify. Do not be that person that cancels things out or reduces things that you're not supposed to do. Questions about number 9? All right, let's start talking about some of these.
Let's get to the last one.
We'll get there eventually. Let's get through the first couple and then we'll get to the last one. How did we factor our numerator?
X method.
We used the x method, and what did we get as our factors?
X minus 6 plus 1.
I think I disagree.
X minus 3.
Good. X minus 3, x minus 2. So if we made our x, 6 on the top, negative 5 on the bottom. We got to multiply to a positive, but add up to a negative. So they both have to be negative numbers. That's why we use negative 3 and negative 2. What about my denominator? We use square roots, and what do we get in our parentheses?
X plus 3.
Good. X minus 3, x plus 3. One of each. What happens now? The x minus 3's can cancel each other out. And what are we left with? X minus 2, x plus 3. Can anything else cancel? No. If you need to keep your parentheses there as a reminder, please do so. Questions about 10? All right. Number 11, how did we factor the numerator? We used the x method, and what did we get?
X minus 5.
Good, x minus 5 and an x minus 4. What about our denominator? X minus 4, x minus 4. Use the x method on both the top and the bottom. What can cancel out? X minus 4s. Now somebody asked a good question about can we cancel out all of these? Unfortunately, no. We've got to cancel them out in pairs. So only one pair of x minus 4s can cancel, which means we still have an x minus 4 in our denominator for our answer. If you want your parentheses, put them there. Questions about 11? All right, the moment Jay Sean has been waiting for. How did we factor our numerator?
Square roots.
Using square roots. So what did we get in our parentheses?
X minus 7. X minus 6.
Good. 1 plus 1 minus. Both of them are x's with 7s. What about our denominator? X minus 7 and x plus 5. I agree. We would use the x method, multiply to negative 35, add up to negative 2. Are we okay with our factoring part? Keon? And the denominator? And the numerator, we had to use our square roots. So one of them gets a plus, one of them gets a minus. All right, what can happen now?
Simplify to x plus 7.
Good, our x minus 7s can cancel each other out. We're left with x plus 7 over x plus 5.